volleyball stood out as the best option to showcase the capabilities of computer vision due to the wide range of poses performed while playing. Consider the different blocking types. Rather than only blocking by raising your hands, I require both elbows to be raised at the shoulder level to force the user to truly extend their arms all the way up to be considered a valid block attempt. Then, depending on where the hands are located relative to the head, using the nose's position as a reference, we can determine where the user intends to block. To simplify things, a jump will be classified as when the user's feet level goes higher than where the knee line was, like so. Of course, this requires calculating the baseline knee level, which is accomplished using this function, which also finds the floor as the average feet Y level, the height as the distance from the floor to your head. Those other baselines are essential in calculating the jump's strength. One does not simply jump. As you can see, I created 5 different functions which help classify if a jumping fundamental is properly executed by the user. These include checking if they lowered their head, bent their knees, and bringing their hands down so they can generate momentum as they raise up for the block. Thresholds were calculated through trial and error for the best user engagement. Every few milliseconds, we add the check value to the pose dictionary, limiting the list size to capture the insights of the last second. The jump power depends on the number of these poses lists, which have a true value. Next, I condense the functionality into a single class named Pose Controller so that I can import it into the game file. It also includes an additional function calculate the user's X position as the middle of their shoulders. I used Pygame to create the game and started by creating the sprites created through Piskel. Next, I had to create the different classes for the player, the spiker, and the back row players. Finally, I had to adjust where the hitbox was located depending on the type of block. Use the pose controller to control the movement of the player, and add collision functionality so the characters would follow, bounce, spike, and block the ball. To play the game, you first need to run the game.py file in its directory so that it can access the images. Next, you will want to take a few feet back away from the camera to ensure that your whole body is in view when you move side to side and jump. Testing this with the classifier.py file is recommended. Next, you will need to right-click on the application to recalculate the baselines and ensure that it is properly tracking you. The key points on the user was found using MediaPipe's pose solution. This project not only included the computer vision task, but also the creation of an entire game using Python. You may have also noticed some lag between my jump and the player's jump. This may be attributed to the update time interval's sensitivity and computational time of tracking many different poses. In the final version, I had to remove some of the pose's consideration to make the game run smoother. Thank you for watching.